Hello everybody, this is Natas level 10 to level 11. So we have a website that says the cookies are protected with XOR encryption or exclusive OR encryption, and a input field labeled background color with this set color submit button, and it seems to take a 6-digit hexadecimal value for the red, green and blue values of the background color. Default set to white, and we can set it to black, for instance, by giving 6 zeros and hitting set color. But that doesn't tell us a whole lot about how we could exploit this to find the password. We could look for errors and see if there's any sort of error that we can produce that might give us some hints, but I'd say let's just look straight at the source code for this one, seeing though we have it. And you can see when we begin to look at the source code that there's more PHP code than in the previous exercises. And at this point, I would not try and tackle the problem by reading all of the code at once. I think it's sometimes easy to do that, to try and understand everything that's going on, but that sort of strategy doesn't really scale very well. As we get more code and more functions, I would suggest finding sort of the most relevant information and then working around that, bringing information in as we need it. So I'll sort of employ that strategy here. I can see that there's some variables, functions being initialized or declared. Some more initialization here. We've got this conditional, which is looking at this request object or variable for the background color, but there's nothing here that sort of suggests password. We've got save data function being used. And then down here we've got this print statement, which is the print statement for the next password for Natas 12. So this is where I would begin working sort of on the exploit. I can see that there's this data variable, and it seems to be an array because it has a show password key. We can index it with show password, and if that's set to yes, then it's going to print the password. So we're guessing that it's currently set to no. So somehow we're going to be looking to find a way to manipulate this data variable, if we can. So that's my first hints. So I would now look to see where this data variable is initialized. And I can see that it's initialized up here. It seems to take the return value of this load data function. That load data function is being passed in an argument of default data. So I'll look at this default data next, and I can see that that's initialized as an array where show password is set to no and the BG color is set to 6Fs. So that corresponds to the sort of starting state of the website. You know, when we first requested the website, that does seem to be the sort of the default state that we experienced. So it does look like this name is quite good for this variable. But that doesn't tell us how to change this show password key. There's no way of setting it yet. So let's look into the load data function to see what's happening there. And so this load data function takes this def parameter, but we know in our case it's going to be passed in this default data array, so we'll have that in our mind. And let's go through this sort of line by line. There's this global cookie line, which if you were to do a Google search for the PHP keyword global, you could see that this imports global variables into local scope, which means that it takes a variable that would normally live outside of the function and make it available within the function. And we have this cookie variable, and that's a super global variable in PHP. Again, you can Google search this. It's a variable that contains, like the sort of the get and the request variable, it contains all of the cookies sent to the server with our HTTP request. And we've looked at cookies in previous exercises, so I won't go into what cookies are, but this is a way that we can access them via PHP on the server. So I'll open up the cookies, which in Chrome you go to the developer tools and then to application. And then in your storage tab, there should be the cookies. And you can see that for Natas 11, we have these 3 cookies, 2 sort of GA cookies and 1 data cookie. And if you click, we can see the value of the cookie here, and we're able to edit the cookie that we send to the server by changing the value in this column here. But if we look back to the function, we can see that we're sort of reassigning this argument we pass into this myData variable. And actually, this myData variable is returned at the end. So we can kind of see that load data is going to return something that looks like an array of show password and BG color if it was to return the default data. We can see that it looks to see if there's an array key existing called data in the cookie variable. So it's looking for this data cookie. And then if it finds that, it initializes a new variable called temp data, which seems to decode. There's like a decode here, an encrypt function here, another decode function call here with that cookie data value. And if we look at our cookie value, you can see it's a random sort of string of characters. So this looks to be sort of encrypted. The initial, when we started the exercise, it sort of mentioned the cookies were encrypted as well. So it seems like this line is sort of decoding the cookie. And then there's this, after this sort of decoding process, there's this if statement that checks to see if that variable is an array, if it contains a show password key, and if it contains a BG color key. If it does, it then checks that the BG color matches a particular pattern, which this is a regular expression, and we can kind of see that it's looking for 6 digits between A and F or a digit. So it's basically checking to see if the BG color value is like a valid hex color. And then if all those conditions are met, we then overwrite myData, which currently looks like this array. We overwrite the show password value with the value we find in the cookie, the decoded cookie, and we overwrite the background color with the background color we find in the decoded cookie. Once all that's done, we return that myData variable, and then that's what's being used in this check. So there's quite a lot of information there. How I would approach this, if it seems overwhelming, is maybe just to write down each sort of step as you go. So you need to understand the flow of the data, and so I've written on this whiteboard sort of like the key points. And I think once we look at these key points, it's maybe more obvious as to what we do, and we can reason about the program a bit simpler. We know that the site will print the password if this data variable has show password as yes. We could see that it was initialized with the return value of the load data function. The load data returns default data unless there is a data cookie that, when decoded, is an array containing a show password key and a BG color key. If so, then it will use those values. And so this is where the exploit is. We needed to find a way that we as a user can override the show password value. So we know that we would like the decoded array, that decoded cookie, to become an array that looks like this. Array show password with yes, and the BG color as any valid hex string. And how do we do that? Well, we need to figure out how to encode. If I look back at the cookie, we need to find how to correctly encode the cookie so that when it's decoded on the server, it's going to look like this. And if it looks like this, then it will reach that data show password check. It will say yes, and it will print the password. So that is the sort of understanding the actual problem, like taking it step by step and understanding where as a user we can influence the decisions being made on the server or the actions being taken by the server. You have to sort of run through the data flow until you find a place where you can sort of set a payload and make the change that you need to see on the server. So I hope that is clear. So that's the problem. So for us to succeed, we need to figure out this encoding. And so that is the next step which we're now about to take. So I've come back to the source code so that we can discuss encrypting our payload to create this cookie value that we will send to the server so that we get the printed password for Natas 12. There's sort of two ways of going around this. We know that at one point in this load data function, we decode this encrypted cookie. And so we could kind of reverse this decoding process to find out the encrypting process. But also this cookie is saved, is created somewhere and will be encrypted. And just glancing through the code, we can see that there is this set cookie function being called here in save data. And it's actually creating this data cookie. We can see that it takes a parameter D and it JSON encodes it, then XOR encrypts it, and finally base64 encodes that. And that's what gives us this cookie value. So this is the process we'll need to follow to take our payload, which is this array here, but with show password being yes, and turn it into this encrypted cookie value. So we know what we need to do. And JSON encode is a PHP inbuilt function, so that's easy to do, as is base64 encode. But there is this XOR encrypt function being used, which is actually created server-side in this script. And that would be easy to use as well. We could create our own PHP script and copy and paste this function. If the function just was self-contained, we could just literally copy paste it and use it exactly the same way that they use it. However, the folks at Natas have censored the key that's being used. And that makes things harder because if we look at this function, we can see that the out text which is returned is created via a process of bitwise exclusive OR sort of operations against this key and a text value. So this key is being used to create the out text is what I'm trying to say. So we need to know the key to be able to use this function correctly. So we need a way to crack this key within the XOR encryption, which isn't self-explanatory. You know, this is something that you would need to research to look into XOR encryption, but you can also sort of reason about it. If you understand how XOR encryption works and you can gather some information, then you can create you can kind of crack the key that way, and that's how I will explain this process. So to talk about how XOR encryption works first, I have just created or in this sort of instance, I have created um, a little example on this whiteboard. What XOR encryption, the way it's being used here is that there is a key of some length and some in text, and we're using the example of hello here, and we're then looping over each character of the text and doing a bitwise OR, exclusive OR operation against the corresponding letter of the key. So, for instance, it would be H, exclusive OR with A, E, exclusive OR with B, L, exclusive OR with C, L, exclusive OR with A, and O, exclusive OR with B. So it kind of, the key repeats, we wrap around, and that is what this modulo function is doing here. It's using the length of the key and it's just wrapping around and repeating the key over and over again. And then how this sort of H bitwise OR with A looks is it takes the binary representation of the particular character. In this case for H we have this binary representation. And then it takes the binary representation for the other letter, A, like this. And we run an exclusive OR bitwise. So that's for every pair of bits. An exclusive OR is 1 if only one of the inputs is 1 and 0 elsewise. So to run through with this, 0 exclusive OR with 1 is 1, 0 and 0, neither of them are set, so it's a 0 as the result. Same for the next bit. Then there's only one of them have been set, so the answer is 1. Both of them are the same, so it's a 0 again. Both of them are the same, so it's a 0 again. Both of them are the same, so it's a 0. So you work through bit by bit or pairwise bits and run an exclusive OR against them to get your result. And so that's what's happening here, is that we're taking the text and we're doing a bitwise OR character by character against the key, and then we're concatenating that with the out text. So we're creating this out text from each of those bitwise OR operations. So that's how the encryption works. And now we need to understand how to get the key from that. So I would say the best way to reason about this is to try and get as much information as we can. And one really good way of doing that would be to find an input for the XOR encryption and to find its corresponding output. That way we can see what an input becomes via this XOR encryption, and then we can try and see if there's a way of reasoning about what the key must have been in that case. And we can actually do this because the encryption uses a JSON encode on this side of the function. Well, that's PHP inbuilt, so we can do that. And on the other side, we have a base 64 encode, so we also know how to do that. And so I've done this here, is that this is the default value for the array. It has a show password no and BG color as all Fs. And we know that JSON encode will encode that to this string. And we can verify that using the interactive shell. If we were to run echo JSON encode on this array, you can see that that's what we get. And similarly, we can go backwards from the cookie that we have, which we know it's here. So we can copy that. And we know that it was the output of the XOR encryption was then base 64 encoded to get this cookie value. And so similarly, we can base 64 decode the cookie value that we have to see what the output of the XOR encryption must have been. So we know that there's an arrow here, an arrow here. Sorry, we know that there's an arrow here that is an XOR encryption that takes this to this. And another thing we can reason about this is because the out text is just the result of a bitwise OR exclusive OR operation between two characters, we know that the length of this must be the same as the length of this string, because it's just this bitwise exclusive OR with a key value will become this, and then this character exclusive OR with the key value will become this. Yeah? So it's done character by character and will return this. So how do we get the key from this knowledge? It all boils down to the fact that the XOR encryption is symmetric. And what I mean by that is that the same key is used to encrypt as well as decrypt the string, the values. If you exclusive OR bitwise the same value against itself, it evaluates to 0. You can go through and see, because everything is going to be paired, they'll all be zeros. And if you bitwise exclusive OR 0 against anything, you'll get the same value. So doing this against any value will just not affect it. And you can use that to cancel out. You can kind of use this in an algebraic way. So I hope that you're still able to follow along with me here, but we can just show by doing like one character. If we look at this curly brackets here, we know that the curly brackets and bitwise exclusive OR with the first character of the key equals 0, right? Because of this input and output that we know. So then what we can do is sort of algebraically, now that we kind of know that this x by itself will make 0, if we were to do something like this, if we were to do this to both sides, yeah, then this will become 0. It will become this, yeah? And then 0, bitwise exclusive OR with the key value, just doesn't do anything. It just leaves the same value. So if we take this and bitwise exclusive OR on both sides, we're going to be able to find the key value at that point. And so that is a way that we can reconstruct the key from the input and the output of the function. If we take every single character and bitwise exclusive OR them against each other, we're going to get every single value of the key. And once we know the key, we can just recreate the function, this XOR encrypting function. We'll have the key, so we can just use it in the exact same way that they did to then encrypt our payload. I hope that makes sense, and we'll now go through the process of creating the PHP script to do this. Okay, so to start, we're going to make a for loop that will run the bitwise exclusive OR against each of the characters, against each of these characters one by one, so that we can reconstruct the key. And I'll do that by creating a natas11.php file. And we're going to have two strings. There's going to be this JSON encoded string here, which is the input. And as you can see, I've got Copilot here and it's trying to talk to me, so I'm going to disable that. And we have an output string which I need to paste in. Notice that I'm using single quotes to encase the string here because it has double quotes within the string itself, and here I've had to use double quotes because it contains a single quote within the string. And we just need to create this for loop. So the for loop is going to have this index I. We're going to loop over the entire string, so we're going to loop over the entire string of A one at a time. And all we're actually doing is echoing the character, each character bitwise exclusive OR with each character of the other string. And as we previously discussed, that's going to reconstruct the key that was used when encrypting with XOR. So that should work. Please ignore the ESLint warning there that I've got. It's just to make sure I properly document everything, but of course this just being a small script, I'm not going to be doing that. So let's run our script. Oh, sorry, PHP. And you can see that we get this output, which is a repetition of characters. It's KNHL and then KNHL repeated over and over again. And that corresponds to the fact that the key has this modulus in it, the same key value. And if you remember from my example here, we sort of use the same key value, we wrap around and repeat the key over and over again to encrypt text. So that's what that's corresponding to. So what that means is the actual key itself is just one of those repetitions. So the key for this XOR encrypt function must be KNHL. So that's what we've been looking for. And now that we have that key, we can use it to encrypt our payload finally, and we'll arrive at an encrypted cookie that we can use to send to the server that will print the password. So to do that, I'm going to copy in this XOR encrypt function that they created. So we'll copy that in. And I think there's a couple of error messages here, yeah. Just format them. So we have this, and we know now that the key is KNHL. We can get rid of these A and B, and the important part for us is that we have our payload, which I'll get from here. It's this array with this no being a yes. That's what we've been after this whole time, but as in encoded form. And so that's what we want to echo. And we know from the setting of the cookie that it's base 64 encoded, XOR encrypted, JSON encoded. So let's copy that exactly. In fact, let's just copy paste that. But this is going to be our payload. Like this, we can save. And so this function call, set of function calls here should take our payload and create the correct encoded cookie that we need to send to the server. So let's see what happens when we run this PHP script. Okay, so we get this string, which looks kind of good, no errors. So I'm going to do the exact same thing. I'm going to use pipe. And I'm piping that into the pasteboard, so it's in my clipboard on the Mac. And now we should just be able to use that cookie value. So if I literally just, we'll go back to the main page, and if I now change this cookie and put our new cookie in by just pasting, you can see that it's now in here is this cookie value. If I now request the page again, yeah, you see it was decoded successfully on the server, and so it triggered that condition that we were looking for, which prints the password for Natas 12. So we're there, we've successfully completed this level. There's quite a lot to go through here, and I realize, still being fairly new to creating these videos, that maybe it wasn't always so clear. So I'm hoping to improve with time on this. But also, please, if there's anything that you see and you need clarification on, please just leave me a message. It will really help me actually to continue with these and to get better at explaining things. Yeah, surprising how tricky that can be sometimes to explain something that you have an intuition on, you know? Okay, well, thank you very much for watching, if you have. And yeah, it seems like they're getting a lot more interesting, so we'll see what the next one brings. Okay, thank you.